Hello and welcome to the architecture series. In this video we're going to talk about attribute values in SQL and how to update your SQL queries to be both more performant and easier to read and keep up to date when working with attribute values. This all pertains to Rock version 18 and later, as they added a number of new features to make this all possible. There are a number of new SQL views available, in fact, one for each model in the database. In this case, we have the attribute value underscore group SQL view that handles all the attribute values for the group table. These all follow the same naming pattern, so your person attribute values you could get to via the attribute value underscore person SQL view. As you can see in the results, you have pretty much everything you would need to work with these attribute values, including the persisted text and HTML values. Working with them along with the group table is fairly simple. We're going to query from our group table and limit it to just those groups of group type ID 25, which is our small groups. Then we're going to join to the attribute value group view and use the group's ID as the view's entity ID. This effectively gives us all attribute values for every group. As you can see below in the results, we have both the topic and age range attributes for each group. Of particular note, result 10 from the marble group age range, this is a default value from the attribute. This is what makes these views so important and useful, is they calculate the default value for you. You don't need to deal with that yourself. So if there is no attribute value row in the database for the marble group, there will be a row in this view and it will have the attribute's default value as its value. So let's take a look at the legacy way to query the attribute value tables. We're going to look for any group that has an age range of 18 to 55. So we select from the group, join to the attribute value table, then join to the attribute table, and then apply our filtering. The problem is this won't include any groups if the default value is 18 to 55. Only groups that have an explicitly set value of 18 to 55. This presents some problems when you have default values. If you don't have default values, this is probably not as much of an issue, but it can move you into a corner down the road when you sort of forget about this and start writing queries around default values, or later change the default age range to 18 to 55. We could update this query to also handle default values, but that gets rather complex. So we're going to set that aside for the moment and look at another legacy query. Assuming we didn't want to necessarily filter, we just wanted to get the age range of all of our small groups, including handling the default value, it would look something like this. We're going to select our top 50 results from group, outer join to the attribute table by the attribute's ID number, outer join to the attribute value table, again using the attribute ID number and the group's ID, and then filter by the group type ID and the attribute's key. We really don't need the final filter on line 62 for checking the key against age range, but we have it there for clarity so that it's easy later to see exactly what attribute we're looking for. Then you notice up in our top select portion, we have this complicated case statement. That's what's handling our default value if the value is blank. But this is rather complex and convoluted. Instead, let's take a look at how to do the same exact query using the new attribute value SQL views. This is the new pattern made available by the new attribute value views in SQL. In this case, we're still selecting from the group, but now we're doing an inner join to our attribute value underscore group view and join on the entity ID to the group's ID. And in this case, we just have to specify which key we want to filter on. Remember, these SQL views handle the default value for us, so we don't have to do any extra logic to do that. You can also easily query and pull back multiple attribute values at the same time. In this case, we're doing pretty much the same query, except we're also pulling in the topic attribute value for each group. So we're selecting from our group, and then we're joining to the attribute value underscore group view for age range, and then joining to the attribute value underscore group for topic. In our where clause, you can see that we're filtering on both age range key for age range and topic key for topic. Now let's talk a little bit about performance and how to make these queries faster. These performant queries are available in ROC 18.3 and later. That is where they added a value checksum column. What this is going to do is allow us to quickly query in the database. The reason it's quick is because there's an index on value checksum. There's no index on value because there's far too many values. In this case, we're trying to find every person who has an ability level of potty trained. To do this, we grab the defined value GUID that represents potty trained and put it in our query. And you notice on the last line where we have and av.valueChecksum equals checksum and then the string of what we want to search for. Of particular note here is the in prefix on the checksum string. Under the hood, SQL Server stores strings as UTF-16 strings. These are denoted by the in letter prefix. Now, normally you don't have to supply this in prefix because SQL does it for you. It will automatically convert an unprefixed string, which is UTF-8, into a UTF-16 string when it stores it in the database. However, because we're calling a function that takes either type of string, we have to specifically tell it that we're using a UTF-16 string, otherwise we'll get the wrong checksum value. Now this query will run without that final value checksum line and give us the same results. However, it will take longer to run and it will consume more resources on the SQL Server. To see how many more resources, let's take a look at the attribute value table where we also have a value checksum column. As you can see, this is a very simple query. We're just selecting any attribute value in the entire database where the value is rock solid church. Down below, you can see that this creates 616 logical reads on the database. If we were to look at the query plan, you'd see that it's scanning the entire attribute value table, every single row in the database, and looking for a value of rock solid church. Again, this is because there's no good way to put an index on value. However, if we modify that query to include the value checksum, you can see that our logical reads has dropped to 10. That's a significant improvement over what we had before. And again, just calling out, when we write our value checksum, we need to prefix our string of rock solid church with the in so that it gives us the right checksum value. Also of note, you need to query both. The checksum is just that, a checksum. Multiple strings of different value could result in the same checksum. So in this case, the SQL engine is able to take our hundreds of thousands of attribute values and filter down to probably a dozen or so with the value checksum. Then that dozen or so rows is filtered further by the specific value check to get the one row that we want. Hopefully this will help you write some better SQL queries and get more performance out of your system. And we look forward to seeing you at the next architecture video.